our next couple of examples are to get us to practice finding the discriminant and then using it to state the roots of each of the equations. So as you can see in this one, part A, our equation is 3x squared minus 5x plus 2 equals 0. So the first thing we're going to do is work out our discriminant, which remember is b squared minus 4ac. So what we have is a being a value of 3, b being a value of minus 5, and c a value of 2. So if we fill those into our equation, b squared minus 4ac, what we end up with then, minus 5 squared, take away 4 times 3 times 2. So we end up with 25/24, which is 1. So we know that 1 is greater than 0. So looking back at our previous notes, we can see that if the discriminant is greater than 0, that means there are two real distinct roots. So basically your quadratic equation is going to cut the x-axis in two separate points. In part B, we're going to be doing exactly the same thing that we did with part A. So for our discriminant, b squared minus 4ac, a is 5, b is a negative 7, and c is 3. Filling that into the equation for discriminant, b squared minus 4ac, we get minus 7 squared minus 4 by 5 by 3, which works out to give us 49, take away 60, which ends up being minus 11. Okay, so what that means, our discriminant has worked out to be negative. It's a value less than 0. So looking back our notes, we can see that if the discriminant is less than 0, it means there are no real roots. So basically, if we were to sketch the curve 5x squared minus 7x plus 3 and to draw it out, it wouldn't cut the x-axis at any point. There are no real roots. So under our last example in this section, this one's slightly different in that we have to find the coefficient of the x squared term. We've been told information about the roots. Generally, when we see a question talking about roots of an equation, we know it's related to the discriminant. So what it's told us is that the quadratic equation has a repeated root. Our knowledge from discriminants should tell us that if something has a repeated root, the discriminant must equal 0. So that's the first thing we're going to put on the page. From here, we're going to follow the same steps as we did in the previous example. We're going to calculate the discriminant. So our value for A is going to stay as A. B is a positive 20 and C is a 25. So what we're going to do is fill it into the equation. So we get 20 squared minus 4 times A times 25, and it has to equal 0 to be a repeated root. Working this out then, we get 400, take away 100A, and it needs to equal 0. So now all we have is a straightforward linear equation. We're trying to solve it and find A. So 100A should equal 400. Divide through by the 100 and we get A to be equal to 4. So if A has a value of 4, then our quadratic equation will have a repeated root.